Okay, so now we're going to talk about quinoline and isoquinoline reactivity and move on to pyrazine synthesis. So remember, before this lecture, you're going to need to have read or have open with you G. Jack Lee's chapter 11 and chapter 5. So we're starting a new heterocycle here in the second half of this lecture. Okay, so again, quinolines and isoquinolines have actually been super in the news right now because they are in the pharmacophore of the drugs that have been emergency approved for COVID-19. So if you look back, both, or actually, no, just one of that component, and that is the chloroquine or the hydroxyquine. So they have the drugs for part of the treatment for COVID-19, which is a combination of chloroquine or hydroxyquine and the antibiotic azithromycin, which we'll talk about sometime next week. Together, those are supposedly effective for somewhat effective for COVID-19, though I think the jury's still out and it's way too early to tell. But in any case, since that's better, literally better than nothing in a lot of cases, it has gotten emergency approval to be used as a drug with the FDA. And of course, the side issue with that is number one, people have already been hoarding the drug. There's already been cases like I was talking about last time of people trying to dose themselves with the drug, and remember that the safe dose is kind of a little too close to the toxic dose for how much you have to take for this to be effective against COVID-19. And the last thing is that we kind of have we don't have enough of it around to be treating people, the amount of people that would need it. And it's also a problem because, especially with the hydroxy quine, people that have lupus and other autoimmune diseases take this regularly. And so if everyone's stockpiling the hydroxyquine, then people that have lupus can't get their management drugs, and then they can start having these really painful and degenerative symptoms of their diseases. So hopefully we'll be able to get production up, and hopefully, because of how drug production has been outsourced to other countries, especially India and China, and also Ireland, hopefully we'll be able to get enough stores of these drugs made. So it's a little bit of there's a lot of different social and economic factors that go into this. Okay, so anyways, here's the two cores, quinoline and isoquinoline. So they differ just in the position of the nitrogen. And quinolines and isoquinolines, they're electron poor molecules. That means that dipole, that the lone pair from the nitrogen is orthogonal. The lone pair for the nitrogen is not in the same plane as the rest of the ring system. And again, we can tell that the quinoline is electron poor because, remember, benzene is basically off our screen here on this chart. Benzene's over here, and everything is going to be downfield relative to benzene. So that means that there is less electron density around all of these protons, so it's electron poor. And similarly, we can see this again in the indoles. And now notice again how 8A and 4A, notice how they're real dinky peaks. And so again, this is due to the fact that they're quaternary carbons. So they're going to show up as real dinky peaks in the carbon NMR spectrum. And you don't have that proton next to them to make them nice and strong. Let's see, what else do I want to do? Tell you about this. I think that's pretty much it. Could say that C2 a lot of is inductively, there's an inductive electron withdrawing group, an electron withdrawing effect at C2, and that's why it's over here. The isoquinolines follow the same trend. Again, they're electron poor. Again, it's pretty easy to tell the difference between a quinoline and an isoquinoline based on the proton NMR. They're very, the electron densities and the splitting patterns are going to be very different. Again, we see this similar C1. We're seeing this electron withdrawing effect over here. We're seeing less of it at C3, but we're still seeing inductively electron withdrawing effect. We're seeing C4 as the most upfield carbon. And again, we're seeing these quaternary carbons are little dinky peaks. Okay, so quinoline and isoquinoline are basic and nucleophilic.